My name is Kari. I run a computer consultancy firm called Mansabs. We are an engineering powerhouse in artificial intelligence and machine learning.
And I'm Alex Kari, going to 8th grade at Odyssey Middle School in Camas, Washington next year. When my dad gave me the AIY kit, I asked my little brother, hey, if you could have an identifier for anything, what would it be? He responded, Pokemon. And that was that.
See, vision leapfrogged living creatures in a big way.
Imagine what vision can do to computing evolution.
So we set out to train a data set with Pokemon images to test out how we can actually utilize a device, such as a Raspberry Pi, to train a model to show how computer vision works with such low-power device as the AIY kit from Google. So,
our project goals were very simple. Don't spend any money at all.
So with that, we had to actually make some choices. We had to choose technologies and resources that are available out there without actually spending money on cloud instances for training or for buying expensive GPU equipment and such. Our tasks were simple. We had to first download a custom image data set. Little did I know, there's about 800 plus Pokemons out there. And you need at least about 100 images of each. And if you do the math, gosh, that's like 80,000 images. That's a lot of data. And we had to use some way to store that data in order for us to train a model on it. And we decided the best alternative out there for training and prototyping on image data sets like that or other machine learning problems is Google Collaboratory, which is a free development environment that actually has a GPU capability, which you can write your own code, test your own code right in the environment in your own web browser without having to put a credit card number to start someone billing you. We also utilized Google Drive, which we realized is the best way to connect that to Collaboratory so you can have persistent storage to keep your images in. Connecting the two was really fun, and it made it really simple for us to go and utilize that and develop our training for classifying, for developing a custom image classifier for Pokemons. Lastly, once we developed that image classifier, our compute graph or model, if you want to call it that, we had to move that over to the AIY kit so we can actually use our AIY kit to perform inference. AIY kit, for those of you who don't know it, consists of a Raspberry Pi, a vision bonnet, and a camera. That's all what's there. It's actually compiled in a box that comes with it, in a cardboard box that comes with it. This big thing here is a battery, but this is how big it is. The Raspberry Pi Zero is a low-powered device. So it turned out for computer vision problems, you don't need that much of a high power if you have a good GPU processor or a good vision processor for your problem.
You can try it for yourself using this URL. Now, let's build our data set.
Before I dive into the data set, I'm going to show you what that URL takes you to really quick. Let me see if I can actually bring that over here. That is Google Collaboratory. Google Collaboratory is a website. You log into it with your Google credentials, and you're able to actually run code right inside of it. It has the description of what you're going to be doing. This is divided into chapters. The first chapter is actually building your image set. I collapsed that on purpose because we already built the data set for you, but I kept it in there in case you actually want to build your own data set of something else. And you could just simply change the search, the API search function, and build your own data set of something you are passionate about. Chapter 2 is where we're actually going to be training our image classifier. And it's so cool in here. this actually allows you to put code snippets in boxes and then come here and run them right there in your browser. It's running in a cloud instance in the Google Cloud Platform, but it's actually supported by a powerful GPU on the back end, which makes it really amazing. And it connects directly to your Google Drive. That gives you access to your to all these directories that hold all of our images of Pokemons. If I can find my mouse back to bring it back here. Okay, here we go. So for building an image data set, first thing we're going to start by connecting to our Google Collaboratory to our Google Drive. Google Collaboratory and Google Drive integrate very seamlessly. All you got to do is run that snippet of code, and it'll actually ask you to authenticate. You authenticate with your Google Drive credentials or your Gmail account, and you have access to whatever it is in your Google Drive to work with here. The cool thing is you and only you have access to it. Nobody else is going to see that unless you purposely give them access to. The next step is actually download and correct the images. So that turned out to be a bigger task than what we had anticipated. It took a couple of weeks of Alex and his brother, Max, actually going through Pokemon images and screening out images that have multiple characters in them, some pretty girl dressed up in Pokemon costume for Halloween, and other images that were, in some cases, inappropriate. So we had to actually go through the images and filter them out. So we make sure we have a clean data set in order for us to use that for training our classifier. We also had to correct those images as we downloaded them. We wanted to make sure that they're all RGB format. We wanted to make sure they are in JPEG. And we wanted to make sure they're all in consistent size. So we built that code Alex wrote that code to actually correct those images and make sure they are all in the right format for our training model. Alex will show you now how to actually retrain your classifier. That's the exciting step where you actually take those images and utilize the power of TensorFlow to actually train a classifier to train on those images.
You can build your own data set of images, or you can use the Pokemon set we built. 2 versions, the full set and the subset of the ones if you want to test it. Below you have the code to verify that you have a GPU, because without a GPU, that'll take a while. In order to build this model, we will be using transfer learning with the mobile net. Transfer learning is when you take the knowledge from one model and you use it on a different data set. Now, we'll have the GPU, which is what the code was for, because you'll either need a GPU or a lot of time. We'll be using it with data stored in our Google Drive because of reasons. Anyway, so not to reinvent the wheel, we will be using code from TensorFlow for Poets. They made a great tutorial of how to do it with flowers. We'll be using the retrain.py script to build the model. We'll also be utilizing augmentation to avoid overfitting. Overfitting is when it gets too used to one picture rather than just the general idea of what it's supposed to be. So we'll be using augmentation, whereas what you flip it, churn it, crop it, etc. Change it, basically. Now, to test it, we downloaded a random picture from the web. We ran our model to predict the label for the image. It was correct.
Okay, thank you, Alex. So once that model has been trained with our image data set, the training process takes anywhere from a few minutes to a few hours, depending on how many augmentation options you've selected. And on the size of your data set, it could take a lot longer than hours if you selected the full data set of all of the 80,000 images plus Pokemons, which are now available on Google Drive if you want to use it. We will take that graph and compile it to put it on our AIY kit or the Raspberry Pi bonnet. Excuse me, I moved too quick. So to compile that, Google made available a compiler, really straightforward, simple, easy to download and uncompress and run. It takes just simply for input the graph which you built and what do you want to call your binary output, the input and output of your neural network and the image size, and boom, it gives you a binary trained model for your AIY kit. All you got to do next is simply copy it to your AIY kit and turn off the AIY kit default demo, which runs the joy detection. It detects as you're smiling or not, and if you frown, it actually frowns back at you. It takes a simple script that is provided on the AIY kit itself with simply the model, the binary model which we copied, the labels file which was generated by the training process, which has the names of our Pokemons, the size of the image, the input and output layer of our neural network, and here we are telling it we want to display only one output. It will display multiple outputs if you told it to based on what's the likeliness or the probability that each of these outputs could be potentially the top one. And we are setting a threshold here of 70%, where if an image is recognized at below 70%, we don't want it to be classified. And we're going to have that preview option to actually see it on the screen. We'll demo that in a second. Go ahead.
If you go to this URL to build a data set of trains, planes, cars, or Star Wars characters, whatever you like, and train your own computer vision model. Have fun.
Before we show the demo, I'd like to invite you all to our TensorFlow, OSCON TensorFlow Northwest party happening at Pioneer Place Mall tomorrow night at 6:30. It's a party that's bringing the local community together with the TensorFlow team and all of you guys. If you would like to, you're welcome to join us. It's mostly intended to be a social, but we are going to have two sessions. Session one is going to be about all the new hot features in TensorFlow 1.9 and the amazing tutorials that came together with it on eager execution. And also, we're going to have an amazing session about how you can make money with TensorFlow. In other words, how do you use your knowledge in TensorFlow to develop your freelancing career, go tour the world, kiteboard in Mexico, and work your own schedule while you write code for TensorFlow. The URL is meetup.com/TensorFlow-Northwest. Please feel free to go and RSVP, and you're welcome to show up and join us for a really fun party. So this is it. May the demo gods be with us. We are going to be demoing the detector after we trained it for a few hours last night. And with that, I want to thank you. So I am going to start with a real Pikachu. These are hard to find, as you all know. I don't see it. What does it say? What the prediction of it is? I'm not sure I'm pointing at it. But actually, Alex is wearing a fun shirt. Let's try Alex's shirt. Here's Pikachu. What's this guy called, Alex?
Bulbasaur.
There we go. How about, what's this guy called? It's not seeing it. Let's try the guy with the big eyes. Okay. Anybody can correct us here if we keep us honest? So there you go, guys. Go train it with whatever you want. Have it catch the next thief trying to steal your house. Thank you all very much, and have a nice evening.